Right now, at this very moment, there may be another version of you listening to these words, breathing, thinking, and wondering the same thing you are. Not in your imagination, not in a dream, but in a universe just as real as this one. In one reality, you made a different choice this morning. In another, history unfolded slightly differently. And in yet another, the universe itself obeys laws unlike our own. This idea sounds unsettling, even absurd, but is not born from fantasy. It is born from physics, from equations so precise they predict reality to astonishing accuracy. And once we take those equations seriously, they begin to whisper a startling message. Reality may be far bigger than we ever imagined. At the heart of this extraordinary idea lies quantum mechanics, the crown jewel of modern physics, and also its greatest source of discomfort. Quantum mechanics does not describe the world the way our senses suggest it should exist. Instead of solid objects following clear paths, it gives us waves of probability, clouds of uncertainty, and particles that refuse to commit to a single state of being. An electron, for example, does not orbit the nucleus like a tiny planet. It exists in many places at once, described by a mathematical object called a wave function. This wave function does not tell us what is, but what could be. What makes quantum mechanics so unsettling is not just its strangeness, but its success. It is the most accurate theory ever devised by human beings. Every transistor in your phone, every laser, every MRI machine relies on it. And yet, when we ask what the wave function actually represents, the theory falls eerily silent. Is it merely a tool for calculating probabilities, or is it a description of reality itself? If we choose the second option, and many physicists do, then we are forced to confront a remarkable conclusion. All possible outcomes described by the wave function must be real in some sense. This is where the idea of multiple realities emerges naturally. When a quantum event occurs, such as an electron passing through a barrier or a particle decaying, the wave function evolves smoothly according to the equation. There is no instruction in the mathematics that says choose one outcome and discard the rest. That instruction was added later by physicists who were uncomfortable with the implications. If we remove that extra assumption and let the equations speak for themselves, we arrive at a picture in which every possible outcome continues to exist, each in its own branch of reality. In this view, reality is not a single line marching forward in time. It is a branching structure, constantly splitting as quantum events unfold. At the microscopic level, these events are happening everywhere, all the time. Particles interact, energies fluctuate, and probabilities resolve not into one outcome, but into many. Each resolution corresponds to a different version of reality, all equally valid, all equally governed by the same physical laws. This is not an exotic interpretation invented to shock people. It is, in many ways, the most concerted interpretation of quantum mechanics because it refuses to add anything extra. There is no mysterious collapse, no special role for human observers, no hidden variables lurking behind the scenes. There is only the wave function, evolving exactly as the equations dictate. The price of this mathematical purity is the acceptance that reality itself is far more expansive than our everyday experience suggests. Once this door is open, the second idea follows almost inevitably. The universe may be constantly splitting, not occasionally, not only during dramatic events, but relentlessly at every moment. Every quantum interaction becomes a fork in the road. The universe does not wait for conscious decisions or human-scale events. It branches when a photon reflects off a mirror, when an atom emits radiation, when a neuron fires in your brain. The branching is continuous, ubiquitous, and unavoidable. This does not mean that we suddenly find ourselves aware of countless realities. On the contrary, something remarkable happens as these branches form. Through a process known as decoherence, each branch becomes isolated from the others. The quantum information that once allowed different possibilities to interfere becomes dispersed into the environment, making recombination practically impossible. Each branch becomes a self-contained universe, complete with its own history, memories, and internal consistency. From the inside, each branch feels perfectly normal. In every branch, observers experience a single outcome and believe it to be the only one. There is no sensation of splitting, no awareness of divergence. Consciousness simply rides along one branch, following one continuous narrative, even though the larger structure of reality has fanned out into many. This leads to a startling shift in how we think about time and causality. In classical physics, the future is a single destination toward which the present moves. In quantum physics, the future is a spectrum of possibilities. In a branching universe, the future is not something that happens, it is something that unfolds in parallel. The universe does not choose one outcome. It allows all outcomes consistent with its laws. And this brings us to the deeply personal implication. If the universe is constantly splitting, then versions of you may be coming into existence all the time. Not poetic versions, physical versions. Each one sharing your past up to a certain moment, then diverging as different quantum outcomes take hold. In one branch, a decision goes one way. In another, it goes another. Each version feels just as real, just as continuous, just as certain of its own existence. This idea often provokes discomfort because it challenges our sense of uniqueness. We like to believe that our path through life is singular, that our story is the story. But physics does not concern itself with our preferences. It concerns itself with consistency, and consistency leads us here. The multiverse is not saying that you are less important because there may be other versions of you. It is saying that the universe is generous, perhaps extravagantly so, in allowing possibilities to exist. The image that emerges is not of a cold, mechanical cosmos, but of a dynamic, creative one. A universe that does not economize on reality, but explores it fully. A universe that does not collapse possibilities prematurely, but lets them unfold according to its deepest laws. In such a universe, existence is not a narrow path, but a vast branching structure, with consciousness tracing one delicate thread through it. And perhaps the most astonishing part of all is that this idea did not come from mysticism or speculation. It came from equations written on chalkboards, tested in laboratories, confirmed by experiments of extraordinary precision. When we ask those equations what reality is really like, they give us an answer that is both humbling and exhilarating. The universe may be far larger than the one we see, and it may be splitting into new versions of itself at every moment. Once we accept that reality may branch into multiple versions, the next question naturally shifts from physics to identity. If the universe allows many outcomes to exist at once, then what does that mean for you as an individual? Are these other versions merely abstract shadows, or are they as real as you are right now? According to the logic of quantum mechanics, these parallel versions are not symbolic or hypothetical. They are physical. They arise from the same wave function, governed by the same equation, evolving in precisely the same lawful way as this universe. The difference is not in their reality, but in their accessibility. Each version of you shares a common past up to a certain point. The same childhood memories, the same formative experiences, the same accumulated history. Then, at a quantum crossroads, perhaps triggered by something as small as a neuron firing slightly earlier or later, the paths diverge. From that moment on, each version follows a different trajectory. One version might take a risk. Another might hesitate. One might experience success, another might face loss. None of these versions is more real than the others. They are all legitimate solutions to the equations of quantum mechanics. This idea unsettles us because it challenges a deeply ingrained belief that identity is singular and indivisible. We intuitively feel that there is only one me, one continuous self traveling through time. But physics suggests that this feeling may be a byproduct of how consciousness experiences reality, not a fundamental property of the universe. Consciousness does not perceive branching. It perceives continuity. It rides along one branch and calls that path my life, even though other branches exist where different versions of that life unfold. Importantly, these parallel versions of you are not copies created later. They are not duplicates spawned after the fact. They are coexisting outcomes of the same physical process. From their own perspective, they are just as original as you are. Each one remembers being you. Each one feels like the central character in their own story. There is no privileged version singled out by the universe. This realization leads us to a powerful and somewhat counterintuitive conclusion. Other versions of you may be physically real, yet forever unreachable. They do not live in distant galaxies or hidden dimensions that could be accessed with advanced technology. They are separated by a barrier far more fundamental than distance. Quantum decoherence isolates these branches so completely that even in principle, communication becomes impossible. The information that distinguishes one branch from another is dispersed into the environment, making recombination effectively forbidden. This is why multiverse is not something we can explore with spaceships or telescopes. No matter how advanced our technology becomes, we are confined to our own branch of reality. The separation is not about energy or engineering. It is about the structure of quantum information itself. Each universe is internally consistent and externally silent. At first glance, this seems disappointing. If other versions of you exist, why can't we meet them? Why can't we learn from their mistakes or borrow their successes? But physics is not obligated to fulfill narrative desires. Its role is to describe what is possible. And what it tells us is both sobering and profound. Reality may be richer than we can ever experience directly. This brings us naturally to the question of meaning. If there are countless versions of you, each making different choices, does any single life path truly matter? The instinctive fear is that individuality dissolves in a sea of alternatives. But this fear arises from confusing existence with experience. You do not experience all branches. You experience one. Meaning is not diluted by what you cannot access. It is defined by what you live through. From your perspective, your choices still carry weight. Your actions still shape your relationships, your achievements, your regrets. The fact that other outcomes occur elsewhere does not erase the consequences in this universe. If anything, it sharpens them. You are not comforted by the successes of your parallel selves. You are not spared the pain of your own mistakes. Responsibility remains intact. This framework also reshapes how we think about chance and regret. In a single universe worldview, we often wonder how different life might have been if we had chosen differently. In a multiverse, those different outcomes may exist, but they offer no solace. You cannot switch branches. You cannot escape your timeline. The multiverse does not grant wish fulfillment. It simply reveals that reality is more permissive than art. Experience suggests. What it does offer, however, is perspective. It tells us that the universe does not judge outcomes. It allows them. Success and failure, joy and loss, courage and hesitation, all are woven into the fabric of reality somewhere. Your task is not to optimize across all universes, but to live fully within the one you inhabit. This understanding carries a subtle form of liberation. You are no longer burdened by the idea that there is one perfect path you must discover or risk cosmic failure. The universe is not keeping score, it is unfolding possibilities. Within that unfolding, you experience one story. That story matters because it is yours, not because it is unique across all reality, but because it is unique to your consciousness. The idea that other versions of you are real yet unreachable forces us to confront the limits of knowledge and control. It reminds us that science can expand our understanding without expanding our power. We can glimpse the architecture of reality without mastering it. And in that gap between understanding and control lies something deeply human: acceptance. In a universe vast enough to contain countless versions of yourself, the miracle is not that alternatives exist. The miracle is that awareness exists at all. That matter, governed by impersonal equations, can give rise to beings who can reflect on their own existence, even when that existence is just one thread in an unimaginably large tapestry. When people first encounter the idea of parallel versions of themselves, one of the immediate reactions is existential panic. If every choice I make is realized somewhere, if every decision branches into multiple outcomes, then what does it mean to choose at all? Does free will evaporate in a universe where everything that can happen does happen? At first glance, the multiverse seems to turn human agency into a cosmetic illusion, a story we tell ourselves while physics quietly carries on without regard for intention. But this fear is rooted in a misunderstanding of what free will actually is. Free will has never meant that the universe bends its laws to accommodate our desires. It has never meant that outcomes are magically exempt from physics. Even in a classical universe, every action you take is constrained by biology, environment, and prior causes. Yet we still meaningfully distinguish between choice and compulsion, between deliberate action and accident. The multiverse does not erase this distinction. It reframes it. In a branching universe, free will is not about preventing other outcomes from occurring. It is about which outcome you experience. Consciousness does not hover above the multiverse, surveying all possibilities. It is embedded within one branch, moving forward with incomplete information, uncertainty, and intention. From your perspective, the future is not a set of already experienced outcomes. It is an open field of possibilities that becomes definite only through action. This distinction is crucial. Physics may allow all outcomes, but experience allows only one. You do not feel the success of your parallel self who made a different choice. You do not suffer the consequences of a mistake that occurred in another branch. You experience this life, this body, this sequence of events, and within that sequence, deliberation matters, effort matters, responsibility matters. In fact, the multiverse may rescue free will from a far more troubling threat, classical determinism. In the old Newtonian picture of the universe, the future was fixed. If you knew the position and velocity of every particle, you could in principle predict everything that would ever happen. In such a universe, free will was not just challenged, it was obliterated. Choice was merely the subjective sensation of an already written script. Quantum mechanics shattered that script. At the fundamental level, the universe does not evolve toward a single inevitable outcome. It evolves toward a spectrum of possibilities. The multiverse takes this seriously. It says the universe does not collapse uncertainty into one answer behind the scenes. It allows uncertainty to unfold into reality. In that unfolding, your conscious path is not predetermined in the classical sense. It is selected through interaction, decision, and experience. Free will, then, is not the power to override physics. It is the freedom to inhabit one branch rather than another through the natural processes of cognition and action. You are not outside the system, but you are not irrelevant within it. Your choices do not eliminate alternatives elsewhere, but they define your lived reality here. This understanding strips free will of mystical baggage and grounds it firmly in physics. It becomes something both more modest and more robust. You are free not because the universe revolves around you, but because it is permissive enough to allow multiple futures and structured enough that your experience traces one of them. This same permissiveness leads directly to another profound question, one that has haunted physics for decades. Why does the universe look the way it does at all? When physicists write down the equations that govern reality, they encounter a startling fact. The constants of nature appear delicately balanced. Gravity is incredibly weak compared to other forces. The masses of particles fall into narrow ranges. The strength of nuclear forces is tuned with extraordinary precision. Change these numbers slightly and the universe becomes sterile. No stars, no chemistry, no life. For a long time, this fine-tuning seemed almost miraculous. It was as if the universe were calibrated with life in mind. This impression made many scientists uneasy. Physics, after all, seeks mechanisms, not intentions. The laws of nature are supposed to explain phenomena, not hint at purpose. And yet, the numbers stubbornly refuse to be random. The multiverse offers a radical but elegant solution. If there is only one universe, then the constants of nature must be explained as uniquely necessary. There would have to be some deep principle forcing them to take exactly these values. But if there are many universes, each with different constants, then the mystery dissolves. Most universes would be lifeless. Some would collapse immediately. Others would expand too quickly for structure to form. A tiny fraction, by pure statistical necessity, would have the right conditions for complexity. We find ourselves in one of those universes not because it was designed for us, but because only such universes can host observers in the first place. This is not a statement about destiny or purpose. It is a statement about selection. You should not be surprised to wake up in a universe compatible with your existence any more than you should be surprised to find yourself on a planet with breathable air. This reasoning is often misunderstood as circular, but it is no more circular than evolutionary biology. We do not say that life exists because the environment was designed for it. We say that life evolved to fit the environment. In a multiverse, universes exist with many different properties, and observers arise only in those compatible with observation. The logic is the same, but the scale is cosmic. What makes this explanation particularly compelling is that it does not arise in isolation. It dovetails with inflationary cosmology, which suggests that space itself may be constantly spawning new regions with different physical characteristics. It aligns with string theory, which predicts an enormous landscape of possible vacuum states, each corresponding to a different universe with different laws. These ideas were developed for entirely different reasons, yet they converge on the same picture, a reality that is not singular but plural. In this framework, the apparent fine-tuning of our universe is no longer a cosmic coincidence demanding special explanation. It is an observational fact filtered through existence itself. We see the universe we see because we could not see any other. This does not cheapen the beauty of the laws of physics. If anything, it enhances it. The universe does not need to be unique to be meaningful. It needs only to be coherent, stable, and rich enough to allow complexity to arise. There is also a subtle philosophical shift here. The laws of physics may not be absolute commandments etched into the fabric of reality. They may be environmental conditions like temperature or pressure, varying from one region of the multiverse to another. What we call fundamental may simply be local. This is a difficult idea to accept, especially for a discipline that has long sought final universal truths. But nature has never promised to satisfy our aesthetic preferences. What it does promise again and again is consistency. The same mathematics that predicts particle interactions also allows a multiplicity of cosmic outcomes. The same equations that describe atoms also describe universes. And when we follow those equations honestly without trimming their implications for comfort, we arrive at a picture of reality that is vast, permissive, and surprisingly generous. In such a reality, free will and fine-tuning are no longer isolated puzzles. They are connected features of a universe that allows possibilities to flourish. You are free, not because the universe is simple, but because it is expansive. The constants of nature allow life not because they were chosen for it, but because in a vast ensemble of possibilities, life will inevitably arise somewhere. And in that somewhere, questions like these will be asked. For decades, ideas like parallel universes and multiple versions of reality were treated as playful thought experiments, entertaining but fundamentally unscientific. They belonged to novels, films, and speculative stories that explored alternate histories and mirror worlds. Scientists, for the most part, kept their distance. Physics was supposed to describe what could be tested, measured, and verified, not what sounded imaginative. And yet, something remarkable has happened over the last century. As our theories have grown deeper and more precise, they have begun to point toward the very ideas that once lived only in fiction. The boundary between imagination and mathematics has quietly dissolved. This is not because physicists have become more poetic. It is because nature has turned out to be far stranger than our intuitions ever prepared us for. Quantum mechanics, when taken seriously, refuses to stay confined to a single outcome. Cosmology, when pushed back to the birth of the universe, refuses to produce just one cosmic beginning. Fundamental theories, when examined closely, refuse to yield a single, inevitable set of laws. Again and again, different branches of physics converge on the same unsettling suggestion: reality may come in plural. What makes this transition from science fiction to science so compelling is that it was never planned. No one set out to prove the multiverse because it sounded exciting. The idea emerged reluctantly, dragged into the open by equations that worked too well to ignore. When scientists tried to simplify reality, it multiplied. When they tried to make it elegant, it became vast. The multiverse is not an act of creative excess. It is an act of mathematical honesty. Of course, skepticism remains healthy and necessary. Physics demands evidence, not just beautiful ideas. And it is true that testing the multiverse directly presents enormous challenges. We cannot build a machine to hop between universes. We cannot send probes across quantum branches. But science has always dealt with the unseen. Atoms were once theoretical. Quarks were once abstractions. Gravitational waves were once mathematical curiosities. In each case, indirect evidence came first, followed by deeper confirmation. The multiverse may follow a similar path. It may leave subtle fingerprints on our universe, statistical patterns, cosmic imprints, or deep consistency across theories that were developed independently. The fact that quantum mechanics, inflationary cosmology, and fundamental physics all hint at multiple realities is not trivial. Independent paths leading to the same destination demand attention. As these ideas mature, they force us to confront a question far older than physics itself. What is humanity's place in the grand scheme of things? Each scientific revolution has displaced us from a position of imagined centrality. We learned that Earth is not the center of the solar system, that the sun is not the center of the galaxy, and that our galaxy is not the center of the cosmos. The multiverse may represent the next step in this progression. Even our universe may not be the main stage of reality. At first, this sounds like an existential demotion. If our universe is just one among many, if countless versions of reality exist without regard for us, then are we insignificant? But significance has never come from size or centrality. A single cell can be more complex than an entire planet. A single thought can reshape history. Importance is not measured by cosmic real estate. In fact, The multiverse reframes human significance in a more subtle and perhaps more meaningful way. In a vast ensemble of universes, most may be lifeless, chaotic, or sterile. The emergence of complexity, awareness, and curiosity may be extraordinarily rare. That rarity does not diminish us. It elevates us. We are not special because the universe revolves around us. We are special because the universe allows, somewhere within its immense structure, beings capable of understanding it. This perspective also reshapes how we think about meaning. Meaning does not need to be written into the fabric of the cosmos to be real. It does not require a unique universe or a privileged position. Meaning arises from experience, from relationships, from understanding, from the act of asking questions in the first place. Even in a multiverse, perhaps especially in a multiverse, the fact that consciousness exists at all is astonishing. There is a quiet irony here. The same laws of physics that strip away comforting illusions also give rise to wonder. They tell us that reality is not small, simple, or finished. It is vast, layered, and still unfolding. And within that unfolding, human curiosity is not an accident. It is a natural consequence of a universe rich enough to generate complexity. Science fiction once imagined parallel worlds as a way to escape reality. Science now considers them as a way to understand it. The goal is not to replace wonder with equations, but to let equations deepen wonder. When mathematics reveals that reality may contain far more than we can ever experience, it does not close the door on mystery. It opens it wider than ever. And perhaps that is the most important shift of all. The multiverse does not answer every question. It raises better ones. It challenges us to think beyond the familiar, to accept that the universe does not owe us simplicity, and to recognize that understanding does not require comfort. In a reality vast enough to contain countless universes, the greatest achievement may be that one small corner of it has learned how to ask why. When we gather all these ideas together, a remarkable picture emerges. Modern physics is quietly telling us that reality may be far larger than a single universe, far richer than a single storyline unfolding in time. Quantum mechanics, cosmology, and our deepest theories all hint that existence is not confined to one outcome, one history, or one version of ourselves. Instead, reality may be an immense tapestry of possibilities, with consciousness experiencing just one delicate thread at a time. This realization is not meant to make us feel small or insignificant. On the contrary, it highlights something extraordinary. In a vast multiverse, where countless realities may exist, there is at least one where atoms have organized themselves into minds capable of wonder, curiosity, and understanding. There is at least one where the universe is not only governed by laws, but also contemplated by those who live within it. That alone gives our existence profound meaning. Your choices still matter. Your experiences are still real. The fact that other versions of reality may exist does not diminish the value of this one. Meaning is not measured by uniqueness across all universes, but by the depth of awareness within a single life. In a cosmos that allows infinite possibilities, the experience of being here now remains rare and precious. Thank you for taking this journey into some of the deepest questions science can ask. Thank you for your curiosity, your imagination, and your willingness to explore ideas that stretch the boundaries of what we think reality is. It is viewers like you who keep the spirit of discovery alive, and who remind us that the greatest adventure is not just somewhere out in the universe, but in our ongoing quest to understand it.